Okay, we're about to do 2004 question 1, but before we do, I want to go over a few concepts that we might need that will help us get through this problem. So the first thing that we're going to need to know, even before we look at the problem, I already can tell you that you need to know that one of the things an integral is used for is if you're given a rate, then the integral of the rate will give you like an accumulation. It'll tell you how many of those things that you were measuring. So if I'm measuring, snowfall per hour, if my rate is snowfall per hour, if I take the integral, it'll tell me how much snowfall. Another thing we're going to need to know is how to know if a function is increasing or decreasing. So a function, I'll just call it f, is increasing when the derivative is positive. And a function is decreasing when the derivative is negative. And you may remember that because look, if f prime is increased, so if the original function is increasing, this is positive slope, which means on the derivative graph, all these values have to be greater than 0, right? Like here's a slope of like 6, here's a slope of maybe 3, here's a slope of 2. So it'll all be positive numbers. If f is decreasing, you're going to have negative slope. So what this part would look like on the derivative graph is all negative numbers. So a derivative graph of this might actually look like positive slopes and then becoming negative slopes about here. Okay, that's just a quick review on that. Another thing we might want to know is average value of a function. Sometimes the key word when you see average is you want to see if it says of a function or like of f of x or of g of x. If you do that, that's the one that you do with the integral. So you take a to b of whatever that function is. I'll just use f of x for the moment. And then since it's an average, you have to divide by b minus a. And in a calculator problem, you can literally just put this in under a math 9. Another thing we need to know for this one is the average rate of change. And this is such a great time to talk about the difference. So the average rate of change is, you may remember from a long time ago, the slope of the secant line. So if I wanted the average rate of change right here, between this point and this point, I literally just need the slope there. And if you recall,